Today we're starting chapter 3. We're going to work on lesson 3.1 and 3.2. And 3.1 starts working on quadratic equations. And I know you have seen those before. Quadratic equations have a squared term, like x squared, and when you graph them, they are a parabola shape. And the parabola can open up, it can open down, and they're going to give you the parabola in some different formats. One is the vertex form. The vertex form is f of x equals a parentheses x minus h squared plus k. Okay, this is the vertex form. So in that formula, you see a letter H and a letter K. And in that formula, that is the vertex. The H and the K give you the vertex of the parabola. And the number in front is A. And if A is positive in your problem, if A is a positive number, like if that would be a positive 2 in the front, if it's positive, then your graph, your parabola, opens up. Then your parabola opens upward. But if A is a negative number, then your graph opens down. Like upside down, like this. You can go up or down. Okay? Now, they'll ask you some things about where this would be on a graph, or name the vertex. We've seen that before, that when they have a number inside of the parentheses, the graph can move left and right. Like I know you've seen before, like function notation, and they say you have what happens when it's f of x plus 3, like that. Well, you see the parentheses, and that generally means then that the graph is shifted horizontally. So if it says plus 3, it's actually the graph, it's like opposite. The graph would move negative 3, like to the left. So the number inside of there, if it says x plus 3, then you're actually going 3 to the left. If it would have said x minus 3, then you go positive 3 to the right. It's the opposite of what it says. And the k number moves the graph up and down, vertically, like on the y-axis, up and down. And that's just the sign as it's stated. All right, so let's talk about how to write an equation if they give you some information, how to write an equation of a quadratic in vertex form. Okay, so let's say it says write an equation for a parabola that has a vertex at -4, -2, and passes through (6, 18). Okay, so the vertex again for this -4, -2, that's H and K. So that those numbers will just go up here in the formula for H and K. Now they gave you another point. Instead of telling you like what A equaled, they didn't tell you what A equals, but they gave you another point. And this other point, that can be X and Y. You can plug that in for X and Y up here in the formula. Okay, so here's an X. What about Y? Well, f of X is like the Y. I know a lot of you already knew that, just restating that. You know, if it says f of X, that's really like a Y. Y equals all this stuff. All right, so our formula, our vertex form again, is f of x equals, or the same as y equals, a 2 x minus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 plus 16 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24 plus 25 plus 26 plus 27 plus 28 plus 29 plus 30 plus 31 plus 32 plus 33 plus 34 plus 35 plus 36 plus 37 plus 38 plus 39 plus 40 plus 41 plus 42 plus 43 plus 44 plus 45 plus 46 plus 47 plus 48 plus 49 plus 50 plus 51 plus 52 plus 53 plus 54 plus 55 plus 56 plus 57 plus 58 plus 59 plus 60 plus 61 plus 62 plus 63 plus 64 plus 65 plus 66 plus 67 plus 68 plus 69 plus 70 plus 71 plus 72 plus 73 plus 74 plus 75 plus 76 plus 77 plus 78 plus 79 plus 80 plus 81 plus 82 plus 83 plus 84 plus 85 plus 86 plus 87 plus 88 plus 89 plus 90 plus 91 plus 92 plus times x minus h squared plus k. We can plug in a lot of these numbers and then we'll be able to figure out the missing variable that we need. Like we have h, we can put that number in, we have k, we have x and y. We don't know what a is, but we could find it. So let's go ahead and plug in all these numbers. So y is 18. I don't know what a is. They didn't tell us that. I have x is 6. H is -4, so it's going to go 6 minus -4, which turns to plus 4. And k is -2. Alright, so if we just do a little math here, like parentheses first, follow your order of operations. 6 plus 4 is 10. Okay, 10 squared is 100, so this is really 100 times a right here. 100a minus 2 equals 18. So then add 2. 18 plus 2 is 20. 20 equals 100a. Divide by 100 and simplify that. 20 over 100 is the same as 1/5. 20 goes into 100 5 times. It's 1/5. So now I found what a equals. So now I could write my final answer. I could write my final answer in this vertex form. When you write your final answer, you need to know what that a is. We just found it. And you need to put in h and k. But you leave the x there and you leave the y or the f of x over here. Alright, so my final answer is f of x equals a, which is 1/5 times x minus h. Okay, h was -4, so x minus -4. It turns to plus 4. X plus 4 squared, and then the k number at the end, minus 2 at the end. And now that's the answer in vertex form. That's the final answer for that one. They might have you graph these on your assignment. So yeah, you could graph this, like now you know where the vertex is, -4, -2. Yeah, they go on to like have you graph these sometimes. If you need to graph it, it should be fairly simple. We could go to -4, -2. Alright, so I just draw a graph. -4, -2. Okay, let me grab my calculator. They have you, besides graphing just the vertex, we could, I mean, the point 618 is kind of high up in the sky. You know, I don't really want to go up to 18. We could get another point on the graph besides -4, -2. We could plug another number into the problem. Like we know we have -4, -2 vertex. That's our vertex. What if you plug another number in for x into this problem? Like what if I put a 0 in the problem? That's kind of easy sometimes to plug in a 0. So just grab a calculator and type it in, like 1/5, parentheses. How about try another number so I can graph another point? How about 0 plus 4 squared, don't forget the squared, minus 2. Okay, I got 1.2. I could graph that, even though it's a decimal, it's pretty easy to graph. 0, 1.2 would be about right here. So the parabola C kind of like would start going like this. This is the center of it, so it just like I knew it's going to go up towards that point on that side. And guess what? Parabolas are symmetrical. You know, this is like the middle of it, so the other side should go up kind of the same way. And I'm just sketching it. You have a graphing tool on your assignment that'll be easy to just plug in 0 and you'll get a point. You can just click on the graph on the point you need. So, all right, now let's keep going. So some problems are in this vertex form, but not all problems are in vertex form. Some are in a standard form. So how do you deal with those kind? If they're in standard form, they're written as ax squared plus bx plus c. This is a standard form. If they're written in this other format, you need to use a formula called axis of symmetry. And I know as soon as I say it, you're going to remember it. To find the axis of symmetry, it's a little formula that goes negative b over 2a. You need to use this formula to start these kind off. So if you're given a problem in standard form, you're going to have to use this axis of symmetry thing. All right, so over here, let's try one. All right, so let's say we had f of x equals negative x squared minus 2x plus 1. So the standard form has ax squared plus bx plus c. You need to look at the numbers by the x squared and by the x, because you need the a and the b, so you could use this little formula. So see, a is like negative 1 in this problem, and b is this number, negative 2. And use the signs, there's a negative there. And c is this last number, but we only need a and b to do this. Okay, so the formula is negative b. This b number's already negative 2, and then it says do negative b. That's like opposite of b. So you just switch the sign to positive 2. You know, like two negatives make a positive. Positive 2 over 2 times a. Well, a is this negative 1 number right here. Okay, so it's 2 divided by negative 2. That's negative 1. All right, so that negative 1 number is the first number of the vertex. This is called the axis of symmetry. It gives you the center of the graph. So it gives you that first number of your vertex. So how do you find a number that goes with it? Well, you grab a calculator and you take this number, negative 1, and you punch it into the problem. Plug it in for x. So I grab my calculator and start typing. Negative 1, there was a negative in front. Don't forget that. There's a negative in front. And then I'm putting in negative 1 squared. See, and I'm using parentheses. Oops, I put too many parentheses signs. Let's do, okay, parentheses negative 1 squared, like that, minus 2 times negative 1 plus 1. So I type it all in my calculator. I plug this negative 1 in, and I got 2. So my vertex on this graph is negative 1, 2. And again, graphing it on the computer won't be that tough, but you might need another point. They tell you to use the intercepts to graph. Use the vertex and intercepts. Well, an intercept is easy. It's when you plug in a 0. If you plug in 0 for x, you're going to get the y-intercept. To find an intercept, to find like a y-intercept, you plug in 0 for x. So it'll just be calculator work again, plug in a 0 in the problem. So it's the same thing, but I'm going to plug in a 0 in the parenthesis, like negative 1 times 0 squared minus 2 times 0. So I'm just going to delete that and show you it's 2 times 0 there, plus 1. See, it's just same problem, but now I'm putting a 0 in there. And it'll give me the answer is 1, because if you have 0 squared is 0, 2 times 0 is 0, you just have the plus 1. So it's 0, 1. So then again, you'll be able to go onto your assignment and work on it, and then you'll be able to graph those points pretty easily. You'll be able to click on the graph, and you know how the graphing tool comes up on your computer, and you'll be able to click on the parabola shape that you need to make. And you go over to negative 1, 2, click on your graph, and then click on 0, 1 that we just got. And if you click on those two points, it'll just draw the graph for you. That's all you have to do is find the vertex, and then this is called like a y-intercept. You put a 0 in the problem and you'll get the y-intercept. And you just click in the center for the vertex, click one more time for the other point, and it'll make the picture for you. So it'll be pretty easy. Alright, so that covers lesson 3.1, and then lesson 3.2 goes into polynomial functions. it goes into graphs that are like, let me move my camera back up. It goes into graphs that are like x to the third power or x to the fourth power. And x to the third power graphs look like that. X to the fourth power graphs look like this. And x to the fifth power, I'll draw one of those, looks something like this. Now I'm just kind of sketching a general shape of them so you can kind of see. The higher the power, the higher the exponent, the more bumps and turns it has in it. So on these kind of graphs, they're going to ask you about the end behavior. Well, all that is looking at the arrows on the ends and telling what the graph is doing. Like right here, it looks like this is pointing up forever, like up into the sky. So you're thinking of like the height of the graph. It's pointing up forever. It's pointing up to positive infinity. So the assignment will say like this graph rises on the right. This is the right side. This graph is rising on the right. Well, this side of the graph, this for y, it looks like it's pointing down to me. And down is negative. This is pointing down to negative infinity. So that's what the ends of this graph is doing. So this graph, this is the left side of the graph. Your assignment will have you pick on the answer that says that it falls on the left side. See, because it's going down on this left side of the graph. But it's rising, it's going up over here, and they'll say it rises on the right side. I've even just said the right side goes to infinity and the left side goes down to negative infinity. That's another, that's what you're thinking about. X to the fourth, you can see that both sides of this one are pointing up. Like both arrows are going up. Like it's rising on the right side and rising on the left side. So if it's an even number, the arrows go the both way, like the same way on the ends, if it's an even power. And if it's an odd number, like 3 is an odd number and 5 is an odd number, then we can see that one arrow is like pointing down and one arrow is pointing up. So this side's, I would say, they say falling or going down to negative infinity, and this side's going up to positive infinity. Okay, now graphs can flip around. We've done reflections before. If this would have been negative x to the fourth power, then the graph would have looked like that. Would have been pointing down on both sides if it has a negative in the front. Same thing with the fifth power. If it would have been negative x to the fifth power, then the graph would have been flipped around the other way, and it would have looked more like this, where this side's pointing up and this side's pointing down. It would be like opposite. It flips the whole thing around. All right, so they'll ask you about the end behavior of the graphs. Like this pointing up to positive infinity on the right side. So they're saying it rises. See, it's like going up to positive infinity on the right. But on the left side, it's going down to negative infinity on the left. So that's all. It's pretty easy. All right. Finally, they get to problems where you have to solve. So not only talking about what the graphs look like, they'll have you find the zeros of the graph. Find zeros. Finding zeros means solve the problem. It's same as solve. It also is the same as find the roots. There's different names for when they tell you they want you to solve the problem. Another name is find the zeros or find the roots. Another name is x-intercepts. Any of those wordings mean solve it. find the zeros, solve the problem, find the roots, find the x-intercepts. It all means the same thing. So they give you a problem like f of x equals x to the third plus 3x squared minus x minus 3. Okay, so let's say that's your problem. So overall, I look at it and I'm like, oh, it's a x to the third graph. I look at the highest power in the problem, x to the third. So I think it's this kind of graph, right? You just think about what kind of graph it is. So when they're asking you to solve it, just so you know what that means, or find the zeros, it means like on a graph, if you had the thing graphed, it means find where it hits the x-axis. Find where it has the x-intercepts, the roots. It's where it hits the x-axis. Like here I just drew one for an example. Doesn't that look like it hits the x-axis 3 times? 1, 2, 3. It has 3 answers. Now, it doesn't have to have 3 answers. This one, the picture I just drew did, but you can draw a picture different ways. I can draw a third power graph that looks like this. How many times does that one hit the x-axis? Well, this one I drew, it only hits the x-axis once. So your answers can vary. I want you to realize that. It's a lot of times there's 3 answers, but not always. This I just drew it and only has 1 answer. Or I could draw it, and draw it again. Or I could draw one that looks like this. I'm trying to just show you that not every problem's the exact same. So I can have a third power graph that has 3 answers, that has 3 zeros, where it hits the x line 3 times. I could have one that has 1 answer, or I could even have one like this where it hits the graph once there, kind of crosses through the graph there once, but here it kind of just like kisses the line. They say it like hits it and turns right away. This one only has 2 answers. They call this like a double root right there, where it just hits it and turns right away. So this one only has 2 answers. Alright, so that's the scenarios that can happen. On an x to the third graph, it could hit the graph 3 times. On the x-axis, it could hit the x-axis just once. It could hit it twice. So we're going to try to figure out the answer. So how do we do that? Well, we take our equation and we need to factor it. Set it equal to 0 because we're finding the zeros or the roots. You set it equal to 0 and you factor it. And when you have 4 items in a problem, you factor by grouping. You factor by grouping because I just know that, like from algebra, they tell you if you have 4 terms in a problem, you can put it in groups. Factor it in groups. So you look for the greatest common factor. GCF, greatest common factor. So the first pair has a greatest common factor of x squared. If I take out x squared, I would be left with x plus 3. Second grouping, oh, they're both negative. I could take out a -1, and then I'd have x plus 3. Factor by grouping is done like that, where you pull out something they have in common. And those things that they had in common were x squared. This group, I divided those by x squared. And the second group we divided by -1. So you write down x squared minus 1. You put those together, those greatest common factors. And then the other parenthesis, these both said x plus 3. You don't have to write x plus 3 squared. You just have to write it once. It's because of how FOIL works, how the distributive property works. We're kind of just condensing this problem and making it simpler so it's not so long and drawn out. This condensed it into 2 parentheses. Then you equal it to 0 and you solve it. You take each parenthesis, x squared minus 1, you equal that to 0 and solve that equation. And x plus 3 equals 0. Set that equal to 0 and solve this problem. Then we'll have it. Okay, so we'd have to add 1, and you get x squared equals 1. And to get rid of the squared, you have to take the square root. When you take the square root, you have to remember that the answer is going to be plus or minus. And then square root of 1 is 1. So square root, when you use that, when you solve, and you have to take a square root, don't forget that you have to have plus or minus. And then the other answer is -3. -3. So this problem ends up having 3 answers. -1, +1, and -3. 3 answers. So it would be something like that first picture I drew. It would have 3 answers, 3 times where it would hit the x-axis. So those are the types of problems you're going to see today. Like solving, you'll have to remember how to factor things. Think about taking out the greatest common factor, and thinking about the shapes of the graphs. Okay, so your assignment's posted on Canvas. Go to your WIT Canvas, and it's lesson 3.1 and 3.2 under the assignments. Same, those computer assignments that we've been working on all semester so far. Okay, so just go to your modules in Canvas for WIT and find your assignment, lesson 3.1 and 3.2, and work on that during class today.